I want to talk a little bit about the graphs of these inverse functions. We're not going to do transformations or anything on these graphs, but it's definitely handy to have seen these, especially the arctan one, which is the nicest one. But we do want to talk a little bit about like domain and range of these functions. So the arcsine one, it's really just going to take that restricted domain of sine and flip it around. So the y values of sine are going to have specifically between -1 and 1 for this graph. And so that means that my x values in arcsine are going to go from -1 to 1. And the x values in the restricted domain go from -π/2 to π/2. And that means that our y values in the inverse function are going to do the same. So I'll just write -π/2 to π/2. And then what we need to do is flip this graph around. So I'm going to try to do this carefully. It's just going to sort of change the concavity of it, or like the curvature of it. And so that point up here at π/2 and 1 becomes 1 and π/2. And then the negatives will go down to the same thing. And so it should look something like that. Like if you flip it, the scale's not super easy to see here, but like you should be able to see that the flipping should look something sort of like this as we draw it down below. So the cosine one is going to look a little bit different here. So I'll do the same analysis. We're going to have my x's from 0 to π/2, and that means that my y's are going to go from, sorry, not 0 to π/2, 0 to pi. And so I'll need a point there. So this one, yeah. And my y's again go between -1 to 1. So my x's are going to do the same. And so if I just kind of try to take these points, I've got that first point at 0 and 1 becomes 1 and 0. And π/2 and 0 becomes 0 and π/2. And pi and -1 becomes -1 and pi. And yeah, so I just need to try to do that flip. You might not be able to see it immediately, but it should look something like this. It looks like a squished version of the arcsine one, only because my scale is different. It is actually just both a horizontal flip and then a shift, a vertical shift as well. But there's actually no stretches at all in this function. It should be the same size really as the arcsine one. But yeah, so this is our cos function. I'm going to just write down these domains as we go. And then finally, the arctan function. So same idea here. My x's are going -π/2 to π/2. So I'm going to just draw those. For my y's. And then y is actually, for this one, y is all real numbers. So it actually goes all the way down to -infinity up to +infinity. So it hits all real numbers. And so when we flip this one around, we're going to actually get a vertical asymptote. Sorry, not vertical. The vertical asymptotes become horizontal. Sort of like how the horizontal asymptotes in your exponential functions become vertical in the logarithm. And we should get this rotation, which is going to give us, so instead of that curling upwards, it's going to kind of curl downwards. 0 and 0 stays the same. And so yeah, so our arctan function is actually this really, really nice curve that has two different horizontal asymptotes on the left side and the right side, and a domain of all real numbers. So it's a pretty nice function. And so we should be able to ask just a couple of questions about this. So yeah, so we can ask some questions about the domain of maybe some transformed arc trig functions. So this first one here, I've got 5 arctan 4 minus x plus 2, and we're talking about the domain. So in general, the domain is going to satisfy that the input is anything in R. Spelling that really strangely. And so basically we are now setting this like 4 minus x equals anything in R. Well, x can be anything. There's no restriction there whatsoever, right? For any x that I plug into 4 minus x, I'm going to get something in R, which is allowed to be plugged into the arctan function. So my domain is all of R. Now, the arc cos does have some restrictions, though. So for this one, for the arc cos, my domain are the outputs of cosine, which means they have to be between -1 and 1. I'm going to actually, instead of writing domain of that, I'm going to say the inputs, not the domain. So I'd have -1 is less than or equal to the input is less than or equal to 1. And so we just get this family of inequalities. -1 is less than or equal to 2x plus 3 is less than or equal to 1. And we just solve this like we would an equation. I'm going to subtract 3 from all sides to get -4 is less than or equal to 2x is less than or equal to -2. And so -2 is less than or equal to x is less than or equal to -1. So my domain is going to be this interval -2 to -1. So yeah, that's how we find these domains, just setting up some inequalities, unless it's tan, in which it's anything.